Okay, so graphing logarithmic equations, we are going to use the fact that we know logs and exponentials are inverses to graph this, okay? So first, let's use the definition to rewrite this. So y equals log base 2 of x. It might help if we reorder this. So log 2 of x equals y. Well, we can change this to an exponential, so that's going to be 2 to the y power equals x. Okay, technically the same exact thing. So that's going to be 2 to the y power equals x. So we're going to graph log base 2 of x by filling in the table below, but we're kind of filling it in backwards because we already have, we're going to have our y's set this time and figure out what our x's are. Okay, so we're going to use that 2 to the y power equals x down here. Okay, so if you plug 0 in for that, you get 1. If you plug 1 in, you get 2. Plug 2 in, you get 4. Plug negative 1 in, you get 1/2. Negative 2 in, you get 1/4. So we can graph this if we go 1/4 negative 2. Oh, I'm not doing that actually. So I did my dots too big. But if we were to graph that point, it would be like right there. And then 1/2, and then 1 0, and then 2 1, and then 4 2. So that's looking like that. Okay, the domain here is 0 to infinity. Range is negative infinity to infinity. And then this is as x goes to 0, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. There's an x-intercept at 1 0 and an asymptote at x equals 0. Okay, and if you look back at your notes from when we were graphing exponentials, you'll notice that a lot of this stuff, like it looks very similar, except for like the domain and range are switched. And the as x goes to is actually on the f of x part. Instead of doing an x-intercept, we were doing a y-intercept before. The asymptotes are y equals instead of x equals. Okay, that's because they're inverses of each other. So this one, again, we're going to do 3 to the y equals x. So that's going to be 1/9, 1/3, 1, 3, and 9. We can graph those. So 1 0, 3 1, 9 2. The domain is 0 to infinity. The range is negative infinity to 0. As x goes to 0, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. X-intercept is at 1 0, and the asymptote is x equals 0. Okay, notice something here. Both of these had an x-intercept at 1 0. And then they both had a point at 3 1. So like whatever this was, they both had a point there at like 3 1. The last one was like 2 1 or whatever the base was. I think it was a 2. But so if that was like log base 10 of x, there would be a point at 10 1. I say that in better words over here. So if you look back at this, so log base 2 of x has the point 2 1 on the graph, and it has an x-intercept at 1 0. Log base 3 of x has a point of 3 1 and an x-intercept at 1 0. So basically, the x-intercepts of both graphs are 1 0, and they both contain the point b comma 1, where b is the base of the logarithm. Okay. Here's some guidelines for this. So basically what this is saying, A is your stretch or your compress. B is just whatever the base is. H is going to move it left or right, and K is going to move it up or down. Okay, and let's look at this. So if we have log base 5 of x, that means we're going to have an x-intercept at 1 0 and a point at 5 1. Now here's a process to do it. I like doing it where we just draw like our new axes. So here, I know my parent function is log base 5 of x, and that minus 3 is going to move it right 3, plus 2 is going to move it up 2. So I'm just going to draw those. Now, I'm going to graph it the same exact way I did the first two, and I'm just going to ignore the minus 3 and the plus 2. Oh, I guess I'm not. Just kidding. I will do it that way in just a second. So here, my x-intercept is 1, 0. So from there, I'm just going to go over 1, and there's 1, 0. And then that point is 5, 1, so I'm going to go over 5 and up 1, and it's right there. And then there's our graph. Okay, you could also do this by drawing a table, doing like 5 to the y power equals x, yada, yada, yada. You'll get those same exact points. Domain here is 3 to infinity. Range is negative infinity to infinity. And behavior, as x goes to 3, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. Our x-intercept, we can't see it easily, so let's solve it. We're going to set this equal to 0. And then we have to solve this for x. So let's start by subtracting that 2 over. Okay, well now this gets kind of complicated. We can switch forms. So we know that we can switch forms, so let's do it. So I'm just gonna do like the e, you know? So that's 5 to the negative second power equals x minus 3, which is 0.04 equals x minus 3. Add the 3 over, so x equals 3.04. Okay, so it's 3.040. Asymptote is at x equals 3. Cool. This one, so our parent function is 1/2 to the x power. It went left 9 and up 4. So let's see. Left 9, up 4. Sorry, I did this in like a backwards order. Now I would fill out the table. So we have 1/2 to the y power equals x. So that's going to be 4, 2, 1, 1/2 and 1/4. So when y is negative 2, oh my goodness, sorry. So 1, 0 right there. And I'm working off the new axis. 1/2, 1. And then, oh my gosh, what am I doing? Okay, sorry. Go back. Ignore everything I just said. So this first point here is 1, 0. So that's this point. 1, 0, not that part. Okay. The second point here is 2, negative 1. And then 4, negative 2. Then we can graph the 1/2 and the 1/4. You don't have to. I mean, you can tell what this is doing from that. So the domain here is negative 9 to infinity. Range is negative infinity to infinity. As x goes to negative 9. Oh, I mixed those up. Sorry, I'm making tons of mistakes in this. Learn from my mistakes, people. So this is going to be as x goes to negative infinity. Oh my goodness. Sorry. That's wrong. As x goes to infinity, f of x goes to negative infinity because this side's going down. And as x goes to negative 9, f of x goes to infinity because that side's going up. Okay, I mixed those two up. So that should be infinity, that should be negative 9. X-intercept, we're going to have to solve it. So subtract the 4. Now we're going to change form. So 1/2 to the negative 4th power equals x plus 9. Well, 1/2 to the negative 4th power is 16. So 16 equals x plus 9. So x equals 7. And our asymptote is at x equals negative 9. Okay. Thanks for watching. Remember to take the quiz. I will go over this more in class. Okay? You guys are awesome. Bye.